Hello, let's work together on this. Let me just grab my pen over here and let's start with the first one over here. So first, when we read the reaction, you need to know how to write down the products, right? That is the first, I think the first barrier for a lot of students. But I can see that you can write down formulas, right? So here I have potassium chromate, and I know that potassium is the group 1 of the periodic table, so the charge is +1. So, and I also know that chromate is a polyatomic ion that is charged to negative. And this you have in the periodic table, and the back of the periodic table that I made available for you, and also in the PowerPoint, where you have a list of polyatomic ions, right? So when you cross here, so we know that is K2CrO4. Is that right? Good. So then it says that we have hydrochloric. So we have this solution, and that forming potassium dichromate. And this will be Cr2O7 and K2, because it's dichromate, right? And also produce potassium chloride. So potassium is group 1, chloride is group 17. So if you see the periodic table over here, look. So we have +1 for group 1, +2 for group 2, 17, we have some valence electrons. So all the atoms in this group need one more electron to be stable like a noble gas. So here will be -1. And here is group 16, so they have 6 valence electrons, so they need 2 to be stable, so -2. So group 16 will be in group 15. Group 15 will be -3, okay? So that's why here I have -1, +1. When you cross, you have potassium chloride. And I also produce water. Wow. Right? So now, what do you have here? 2 potassiums, 2 potassiums. And I have 2 chromates. See 2 chromiums over here? 2 chromiums. So, and here I only have 1. So I need to add 2 more. So now I'm gonna have 4 potassium, 2 chromates and 2 chromiums, sorry, and 8 oxygen, right? So because we multiply by each element over here, so I have a 2 potassium, so it will be 4 potassium, so chromium will be 2 chromiums, and oxygen will be 2 times 4, 8 in this side, right? And now I have 1 potassium plus 2 will be 3, so but here this side I have 4. So if I add 2 over here, so I'm gonna have a 2 plus 2 will be 4, right? And now I have 2 chlorides, right? So I have 4 potassium, chromium I have 2, oxygen I still have 7 plus 1 is 8, and now I have, look here I have 1, and here I have 2, and the hydrogen on this side I have 2, and here I only have 1. So to fix this, I'm gonna add 2 over here, so now I'm gonna have 2 and 2, so everybody's matching, see? So my reaction is well balanced. Now I'm gonna write down the ionic reaction. Remember, only aqueous will ionize. In this case, all, it's all equals over here, right? So I have 2 times 2 is 4. The charge of the potassium is +1, right? And I have chromate over here. So chromate will be in the form of chromate. So you will not separate polyatomic ions. And we know the charge is -2. And I have 2, right? So it will be 2 chromate -2. Plus, I have this 2 hydrogen. It's all equals. So 2 hydrogen plus 2 chloride, right? All equals. And then we have on this side over here 2 potassium plus 1 dichromate over here, 2 negative. It's all equals. And then I have 2 potassium plus 2 chlorides. Oh, sorry. Let me erase this. Okay, so -1 equals plus 2 hydrogen over here, right? Plus oxygen. -2. No, we don't do this. Why? Because here we have liquid. So all the time that you form water will be liquid. So it's wrong to do this, okay? I was doing just to call your attention. So we don't do with liquid. Remember, just aqueous will ionize. So that means liquid, solid, and gas will stay in the same form, will not ionize, okay? So let's get back over here. So it will be water. Good. So now let's look to both sides of the reaction. We have the reactant in this side and we have the product in this side. The arrow separate both sides, right? So let's see potassium. I have 4 potassium on this side and I have 2 plus 2 in this side. So this is only spectators because we can see that they don't participate forming another product. Actually, they come to the reaction and leave in the same way. So now we're gonna look to this one over here. Do I have this ion, the same ion on the other side? No, see, this is not a spectator. So let's go to the hydrogen over here. So I have a 2 hydrogen ion. Do I have this on the other side? No as well, right? So, and let's look to chloride. So I have 2 chlorides over here and 2 chlorides over here. So we're gonna cut this out. See, now we're gonna repeat only the ones that you were not a spectator here. So I have this equals plus 2 hydrogen ion forming what? What are you gonna see on the other side? Dichromate, right? Plus water liquid. Okay, this is our net ionic equation, and this is our ionic equation. Okay, let's do one more just to make sure you understand that. Let's go down over here and let's bring this over here. So this over here, let's work. So here we have hydrogen peroxide. So they are telling me that we have a catalyst. So we use a catalyst in order to accelerate the process, to increase the speed of the reaction. Okay, so the catalyst will not influence or produce any other product. So what you're gonna see over here is just the use of some element or compound that is used to in order to or increase the speed of the reaction or reduce. In this case is to increase, otherwise this will take a long time. So normally as a catalyst, we can use different types of catalysts, but here the goal is to understand that this catalyst will not change anything in the product. It's only to increase the speed of the reaction, okay? So hydrogen peroxide, so we have an aqueous solution over here, right? We're gonna produce water plus oxygen gas, okay? So this is what you produce, a liquid and a gas, right? So that means I really don't understand why you use this over here. Now I understand, because you taught that you should use the manganese oxide over here as a reactant, but here is a catalyst, okay? So you can see here that we produce only water and oxygen. The catalyst normally will appear here, okay? So that is the catalyst that we're gonna see over here. And then decomposition reaction that you can see over here is a reaction that one compound will separate, producing two other compounds or elements. So we don't see if you have two reactants that will be and form one will be synthesis, right? And that can happen, for example, with magnesium and oxygen. So we can use heat as a catalyst. It's a good example of other way that we use catalyst, okay? So here the catalyst, instead of write down catalyst, I'm gonna use here the triangle, just to show you. When you see here, we're using heat as a catalyst to produce magnesium oxide. So here, it's a balanced reaction. So, and that will be a solid. So this is a synthesis reaction where we use a catalyst, and here is the decomposition reaction where we're using the catalyst. See that the catalyst, it's appear over here under the arrow. So you don't use this catalyst as reactant over here. So that is very important to understand here, because otherwise it's pretty common to get confused with this, and it's pretty understandable, mainly when you're just starting to study chemistry. It's a brand new subject, right? So, and what about the reactions, right? So this will be the molecular equation, but we don't have ionic equation, and we don't have, of course, the net ionic equation in this case, okay? Because if you look at, we have a liquid and gas. Remember that they will not separate? Yes, they will not separate over here. And another thing that is missing over here, and probably you already noticed, is that my reaction over here is not completely right. And why? Because it's not well balanced. I can see that I have two oxygen over here, right? So in this side, I have two oxygens and two hydrogen. While on this side over here, I have two, let's put oxygen the same. So 3 oxygen and a hydrogen, I have 2. So I need to fix that, right? So how am I gonna fix this reaction? So if I add 2 over here, I'm gonna have 4, and I'm gonna have 4 oxygen, right? So now if I add 2 over here, I'm gonna have 4, and I'm gonna have 4 in the total because I have 2 of oxygen over here plus 2 oxygen over here, so I have 4 oxygen over here, right? So now it's well balanced and good to go in any kind of stoichiometric problem, for example. Okay, that's it. That's all. I hope you got it. If you still have a question, please let me know.